So, for today, we're going to be looking at orthographic projection. And you're going to have to remember what isometric projection is, right? So, from what we did last term, you should remember that isometric projection is used for representing objects in 3D or drawing them in 3D, right? Which is three-dimensional, right? And you know that usually when you represent objects in 3 dimensions, it always has a width, length, and height, right? Now, in orthographic projection, we're going to be drawing the same objects again. However, you're representing them in a 2 dimensional plane, or you're representing them in 2 dimensions, right? That's the difference between isometric and orthographic projection. So if you look at the drawing there, right, that's shown in this recording, right, you can see you have an isometric projection of a rectangular prism, right? And when you have to draw this in orthographic projection, you represent the drawings in something called views, or another word that's also used is elevation, right? So in orthographic projection, you have 3 types of views, or you have 3 types of elevations, right? And these are the front, end, and plan elevations, or you can say front end and plan views, right? So when you look at the words front and end, that's pretty straightforward, right? When you're referring to the front of an object, you're talking about what you would see from the front, right? And when you're talking about the end of an object, you're talking about what you see from the end, right? That's pretty straightforward. But what does the word plan mean, right? In this case, plan is telling you what you see from the top of the object, right? Or the aerial view of the object, right? If you have to look at it from the top. So we're going to look at each view here in this drawing, and we're going to go through each of them, right? You have the front there first, and obviously when you look at the rectangular prism from the front, you would see the length and the height, right? And it's represented there in 2D as that rectangle there, right? You can see it says a view of the front as seen in the direction of arrow X, right? The width of the object is not given. Why is the width of the object is not given? The reason for this is because when you view this object from the front, you would only see the length and the height. You would not see the width, right? When you view it directly from the front. So moving on to the end view now, right? A view of the end as seen in the direction of arrow Y. The length of the object is not given because when you look at the object from the end, you only see the width and the height, right? As shown there in the end view. So looking at the final view now, which is the plan view, right? You can see that it's seen from the direction of arrow Z, right? That's the view of the top. And when you view this rectangular prism from the top, you would only see the length and the width. You wouldn't see any other dimension, right? So this is how orthographic projection is represented, right? It's always represented by these 3 views: front, end, and plan, right? So you're viewing the object from 3 different angles, or you're viewing the object from 3 different elevations. So if I move on to the next page in the PDF here, you can see that they're showing you another example, right? This time you have a triangular prism, right? And the PDF shows you each of the views, the front end and plan, and it explains to you from which angle, right, you get the front end and plan from. Other than the triangular prism, it's also showing you a cylinder, right? And it's also showing you the views of the cylinder, right? All three of the views. So whenever you're drawing objects in orthographic projection, you're always going to be making use of the vertical and horizontal planes, right? What are the vertical and horizontal planes? If you look at the matchbox that they're showing here, right, you can see the vertical plane is where you would view the front from, right? Where you would view the front elevation from. And the horizontal plane is where you would view the plan elevation from, right? It's showing you there on the diagram. So it's showing you how the front is projected on the vertical plane, and it's also showing you how the plan view is projected on the horizontal plane, right? And it's showing you how it helps you to draw the front elevation and the plan elevation. So moving on, right, we're going to look at the types of orthographic projection, right? And the first type that we're going to look at is force angle projection. So in force angle projection, you always draw the three views in a specific order, or you draw the three views in a specific position, right? In the diagram at the bottom right of the page here, right, you can see that for force angle projection, you have the front elevation being above the plan elevation, right? So whenever you're drawing an object in force angle projection, you always have to use this specific order, right? The front elevation has to be above the plan elevation, right? That's a must. So moving on to third angle projection, right? You can see that instead of having the front above the plan, you have the plan being drawn above the front, right? You can see that in the diagram there. So if I go back to the force angle projection, you can see that you have the vertical plane above the horizontal plane, right? And because of this, you would have the front elevation being above the plan elevation. And if you look at the third angle projection, you have the horizontal plane being above the vertical plane. And this would end up having the plan elevation above the front elevation, right? And this is what determines the position of the views or the order of the views, right? So moving on to the last page here in the PDF, right? It has two worked examples which we're going to look at next week, right? And the two work examples show you the force angle projection and the third angle projection, right? The first example there has a third angle projection worked, and sorry, both of them are third angle projection, right? Both of them are third angle projection. Because if you look at the symbol there, right, both of the symbols are the same and both of them represent third angle projection. So if I go back, right, to where third angle projection is, you can see at the left there, right, let me just circle it. You can see that that symbol there is for third angle projection, right? And if you want me to show you the symbol for first angle projection, let me just scroll back. Alright, they don't have the symbol here, but when we look at first angle projection, I would show you the symbol. Alright? So for next week, we're going to look at third angle projection. And when we're finished with third angle projection, then we're going to move on to first angle projection. Alright? I'm going to show you how the views are drawn, how we get the views, and the order in which you draw them. Alright? Using the same examples in this PDF here.